Welcome back to our video series on creating a data visualization and analyzer for the coronavirus data. In this video, we will be going over how to update our data. So this is my last video in this series, in this particular series. So what you can see here on our to-do list, we've done everything that I have listed here. Like I said, we're going to go over how to update data today. And then your assignment for this week is going to be to write the front-end UI for this program, which we've done before in other programs where we have a main function and it asks, what do you want to do? And then the user has the option 1, 2, 3, 4, 5, whatever. So that's what you'll be writing this week on your own. And then you'll be submitting a video along with the code, of course, and through GitHub, a video on Google Classroom showing your program running and showing your UI in action. So without further ado, let's go ahead and get our data updating. This is actually easier than you might think. So Python comes with a library called urllib. So we're going to import urllib. And what it is a URL library. And so what we can do is if you recall, when we first started this project, we started off, here's our instructions, and we started off by going to a folder of another repository on GitHub. Okay, so I'm going to go ahead and go to that folder. I already have it open here. And inside that folder, there were these time series. And a couple of the file that we actually started off with is no longer there, or that, let me rephrase, that I started off with. If you started later, you may have missed these files and may have just jumped straight to one of these, but that's okay. We are going to be using this confirmed global as our file. Okay, so I'm going to go ahead and click on that file. And once that file opens, you'll notice it's in the same format we've been working with. We have the province, the country, latitude, longitude, and then the dates. So we're going to click on this button raw. And the link to download this file is right here in the URL. Okay, so we're going to copy this. Okay. So let's go back to our code now. And we're going to go ahead and write a method as part of our COVID data class here. And so we already have load data, but we're going to go ahead and write a method called update data. Now we're not always going to want to update the data. This file that we just looked at, like right now, if I go back here, if we go back to it really quick. So right now, if we look at it, we can see that the file is about 65 kilobytes, but this file could grow really large potentially. So we don't necessarily, every time we run our program, want to update the data. That's actually going to be a user option. It's going to be, do you essentially want to update the data? And so update data is going to be a method that might get called, but it might not. And so that's why we're separating load data and update data. They're two different things. Okay. So going back to our code here, I've got my update data method. And in this method, we're going to go ahead and make a variable. I'm just going to call it URL, and I'm going to paste in that URL. It's kind of long, but there we go. And so to download the CSV file, it's actually pretty easy. So inside of the URL lib, there is a request class, and this class has a method called URL retrieve. And this takes in a URL and then a file name to store that URL at. And so we're going to call this confirmed data.csv. Okay. And that's all there is to it to update the data. So to test that, let's go down to our main function down here. And we're going to go ahead, I commented everything else out here. We're just going to say c.updateData. And then we'll go ahead and run this. I think it must be, sorry, my import's wrong. Should be import URL lib dot request. Okay, so let's try that again. So again, the change there was urllib.request is required. Okay, And so now if we look over here in our folder, there's a new file called confirmeddata.csv. If I click on that, we can see that this is formatted the same way as our time series is. Okay, and if we scroll across, we can see that now the last date is, as of this date, when I'm recording this, April 12th. You might see April 13th or 14th, depends on what day you start this. But it should be the most recent data. So that's good. So now what that means is right here for CSV file name, we no longer want to use time series 19 blah blah blah. We're going to use confirmed data.csv. Okay, and so now what this should allow us to do, allows us to update it whenever we want, but now we can run all of our other methods using updated information. All right. So now we have all this nice updated information where we can see that on April 12th we had 28,000 new cases, growth of 5.5%. Right, so we can see that the number of cases is still increasing, but it is increasing at a smaller percentage of the previous day, if nothing else. So that's good. You can see that. If we scroll up here, we can see that our model is completely broken. Right, you see that? Our model is completely broken if we use all of this data. Okay, so what that means is we actually need to adjust things a bit. Okay, our start at can't simply be 30. Okay, it can't be 30 because again we have so many different things happening here in our data. So what we're going to do is, instead of hard coding start at right here, is we need to basically calculate start at. Start at should be remember, we want to go 30 days before now, right? Not necessarily 30 days from the beginning of the data. Okay. Let me see if I can demonstrate. If I change this to 60, for example, and I run our program now, right? Then we can start sort of see what's happening. Right, then we can see what's going on here, and suddenly our predictions, right, while they're way off, they're at least, I mean, sort of reasonable. But also notice then it starts on this March 22nd date. Okay, so what we're going to need to do is, instead of hard coding this start at, we're going to have to say, you know what, we're just going to look back, let's say a fixed number of days from current, right? So like 20 days. Okay, and I think, and if the closer we get to like our current date, the more accurate our model should be, because it's going to take in new things. Okay, so any place where we said start at, right, we're going to need to do a kind of a correction there, right? What we're going to do is go ahead and make an instance variable called self.startat. And we're going to set it equal to the length of self.dates minus 20. So it's going to go 20 days prior in our model. Now notice this is after self.loadDate, but before self.getModel. Okay. Now what I want to do is, every place where I see start at, I'm going to replace with self.startat. So I hit Control F. Okay. I'm going to type in start_at. Notice all caps. I'm going to make sure that I click right here to match case. I only have 8 of them. You might have more. I then click this arrow and I change it to self.startat. And now if I press enter, it's going to go through and it's going to, I'm going to look at it, make sure I do want to change it, but it should go through and change all of these start ats to self.startat. Now this very first one here doesn't really make any sense anymore. So I'm going to go ahead and delete that. Okay. And then we'll save. Now if we run this, we should get, there we go. And we can see the red dots compared with the exponential curve here. Now notice that the days here, it's still showing all the way back to the beginning, because that's how we wrote that method. But for predictions, Right, predictions are only going back 20 days, which again, that's going to have to happen because our model is only going to be very accurate in small areas. So we can see that, on, again, this data was updated last on April the 12th. So it was about 45,000 too high, right? Now the other thing to keep in mind would be we could narrow this down. We could say, you know what, let's only look 10 days in the past. Right? And so now if we run it, right, so we see the 10 days in the past and then the prediction. Okay, and then if we look at the actual data here, we can see that it's even closer, right? And so the smaller this range is that we put right here, the closer our model will be. Okay, so I think what we should do is I'm going to put in here a variable. I'm just going to say range, and so then we'll say range. So in other words, when we create our COVID data object, we can tell it what kind of date range. So down here, when we make our COVID data, we can say, you know what, I want to do one with a range of 5 days. All right? And so now if we do that and we run our code, we see, okay, there's the 5 days. We can see the prediction because we're predicting however far out. And now you can see that that 1 day prediction, we're within 3,000. So these are actually pretty close, which means, seeing 595,000 cases tomorrow isn't going to be that far off, possibly. Okay. So yeah, that's going to do it for this video. I hope you've enjoyed this. I hope you've learned something. Again, there's a lot of interesting things you can do here, and thanks for watching.